Hello and what's up? So today we're going to learn about factoring quadratics. We're going to start off with the basic form of factoring. So that's just factoring quadratic. So x squared plus 7x plus 12, right? So this is your basic for quadratic where its lead coefficient is 1. That makes it the easiest. The way we have to do this is you have to start by looking at your constant all the way at the end, right? So we're looking at 12. And I need to think of the factors of 12. So remember, a factor are the two numbers that multiply together to give us 12. So that's going to be 1 and 12, 2 and 6, 3 and 4. So I need to figure out, okay, which of these factors can I add together or subtract to give us 7? Now, we know that both of these either have to be positive or negative because when they multiply, they give us a positive 12. So they both have to be the same. But then the middle coefficient of the plus 7 tells us they have to add up to a positive 7. So since they're both positive, that's going to be 3 and 4, right? 3 plus 4 gives us that 7. That means when we factor, we're going to break it up. So our leading, we take our lead and we get x plus 3 and then x plus 4. And this is our factor version of x squared plus 7x plus 12. Right? Just to double check and to kind of give you an understanding of what this is. You don't have to do this, but if we use our FOIL method, our first x times x gives us x squared. Outer x times 4 gives us 4x. Inner 3 times x gives us 3x. And the last 3 times 4 gives us plus 12. And then we just combine our like terms. That gives us x squared plus 7x plus 12. Brings us back to what we originally started with. All right. So this is an example of how we could factor, right? So our factored answer would be, I'm going to get rid of all this side work that we did here, right? Get rid of all this, all of our check answer. We don't need that there. This would be our answer right here. It would be x plus 3 and x plus 4. Those are the factors of that quadratic. So try the next one yourself. Pause the video, try it. If you did pause, awesome. If you tried it and you got it right, cool. Let's check it. If you don't know you got it right, let's check it anyway. We're going to do the work. If you're super confident, you can always skip ahead. But we want the factors of 20. So I'm going to do 20, and we want my factors. That's 1 and 20, 2 and 10, 5 and 4, or 4 and 5. I don't know why my brain went to 5, but whatever. Now, I need to figure out what gives me -9. Well, if we're adding these two, because we know they have to be the same, so that means we're adding. That gives me 21, that gives me 12, 5 and 4 give me 9. But notice this is a -9, which means both of these have to be negative numbers, because a negative times a negative would give me that positive 20, but when we add them together, it would give me the -9. This means this factor is going to look like this, x minus 5 or x minus 4. It doesn't matter which one you put first. And then the other one here, x minus 4. Since I put x minus 5 and x minus 4, boom. Once again, if we did our FOIL method, you could always check it. X times x is x squared. X times -4, -4x. -5 times x is -5x. Combine those two, that would give me -9x. -5 times -4 would be -20, right? So it would bring us back to what we needed. But this is our answer for that factored. So this is how we do our quadratics. This is the simple version with a leading coefficient of 1. We could always crank it up and get a leading coefficient that's not 1. Now, these are going to be done a little bit different. It does make it a little harder, but not too crazy, right? But we do have to think a little bit here. So we already know that we're going to take our last one, so 3. And I want to get my factors of 3. This one's easy. It's just 1 and 3, right? But now we need this factor of 2, which is just 1 and 2. And I need to figure out how can I combine these. So you need to do a little bit of mental math. What can I multiply together and then add to get 5, right? So what I see here is if I do 1 times 1, that's 1, and 3 times 2, that's 6. 6 plus 1 is 7. That does not work, right? But I could do 1 times 3 is 3, and 1 times 2 is 2. And 3 plus 2 is 5. That gives me what I need. So then how do we write this? So start with your x, right? This is coming from here. And I need this to multiply with my 3. So my 3 is not going to be in this bracket. So we're going to do x plus 1. And my next one is going to be, take the 2, because this is for your 2x plus 3. Now, this one you might want to do a little double check in your head. 2x plus times x is 2x. X times 3 is 3x. 1 times 2x is 2x, and 1 times 3 is 3. I'm not going to go through and simplify this all, but now I could see 2x. Oh, sorry, that should be 2x squared. X times 2x is 2x squared. I apologize. So that's 2x squared. And then we have 3x and 2x, which gives me that 5x. And then we have our 3 at the end, which shows me that, yes, this is my answer. Now, this one, once again, I know these are a little more difficult, but try the next one. Pause the video, try it yourself. If you did pause, awesome. And let's see what this answer is. So once again, we need our factors of 12. Actually, I'm going to do my factor of 3 first, since that's going to be your leading. The factor of 3, easy. 3 is just 1 and 3. And then we have 12, which would be 1 and 12, 2 and 6, 3 and 4, right? We need to figure out how can we get a 12 here, right? So how do we get a 12? We know we have to multiply something with this 3, and then we know we have this, we have that there, right? So I immediately recognize that the 1 and 12 are not going to work, because when we multiply by 3, that could give us 15, or it could give us 36, 37, you know? But then I look here, 3 times 2 is 6, and 1 times 6 is 6. That would give me 12. But once again, this is negative, so we're going to need minus signs in this. So up front, I'm going to start with my x from this 1, so 1x. And I want this 1 to multiply with the 6, right? So that means 6 cannot be in this bracket. So I'm going to do x minus 2, because we need the negative to get a negative 12. And then we need another negative to get this positive 12 here, because a negative times a negative is a positive. But here I used my 1 already, so now I'm going to take 3x minus, and I didn't use the 6 yet, because we're using this here. So I'm going to do minus 6, right? Once again, you could check your work by doing the FOIL. X times 3x is 3x squared. X times negative 6 is minus 6x. Negative 2 times 3x is minus 6x. So minus 6x and minus 6x gives us that negative 12. And that tells me, yes, this is my answer. And there we go. We have factored another problem. So let's move to another method using our quadratic formula. Now, you could use this quadratic formula to get your answers or your zeros, right? So using your quadratic formula, it lets you solve for this, right? So if I go back actually real quick, we could solve, even I'll go back to this one, right? I could solve for 0. So if I said that my original equation was 0 equal to 0, right? We could find out what the values of x are to give us that 0, right? The way we would do this is, since we could use our multiplicative property, I always have a hard time saying that, you could come back here and we could say x plus 3 equals 0, or x plus 4 equals 0. And then you just solve for this. So minus 3, that gives me x equals negative 3, minus 4, or x equals negative 4. That means if I plugged in a negative 3 to this equation, it would then equal 0. Or if I plug in a negative 4, it would also equal 0. So these are our zeros of this quadratic equation. You could do the same thing for the next one, and you got x equals 5 or x equals 4. And then you could even do it when you have something like this. So for instance, on this second one here, it would end up being x minus 2 equals 0, or 3x minus 6 equals 0. So this would be plus 2, so x equals 2, or 3x, we would add 6, so then that would give us 3x equals 6 divided by 3, x equals 2, right? So this one only has one solution. Even though they look different, it ends up being x equals 2 for both of them, right? So that's a cool thing that you can recognize too. So as we move forward, we come to here, right? We get solve this using our quadratic. Now, our quadratic looks like this. If you look in the top right of the screen, we have our lead coefficient as a. The coefficient on x is going to be called b, and then our constant is c. And then we plug it into what we call our quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. So what I like to do is kind of write out a is equal, in this one, it's equal to 1. B is equal to negative 3. And then C is equal to negative 10. And now we can plug it into that quadratic. I recommend rewriting your quadratic every time you use it. I'm not going to do it just for space purposes on this one. But we get negative 3. But it's a negative b up front. So the negative and negative make a positive. Plus or minus the square root of b squared. So I like to put my negative 3 in parentheses, squared, minus 4 times a, which is 1, times c, which is negative 10. All over 2a. So 2 times 1. And now we can start solving this. Well, 3 stays up front, plus or minus square root. Negative 3 squared. Negative 3 times negative 3 is 9. Minus 4 times 1 times 10. So 4 times 1 is 4. Now 4 times negative 10 is negative 40. But we have that minus sign in the middle. Minus and the negative make it a plus 40. All over 2. 2 times 1 is 2. So now we just add. So we get 3 plus or minus square root of 49, which is nice because the square root of 49 is a whole number. If this, it is a perfect square. If this is not a perfect square, we would just leave this looking like this. Is it pretty? No, but it's prettier than what we would get if we did the square root and then did the plus and minus and all that, right? Because you'd have an irrational number which goes on forever. But I could take the square root of 49. This then means this is equal to 3 plus or minus 7 over 2, which means I have to break this into two possible answers. 3 plus 7 over 2 or 3 minus 7 over 2, right? Up top, this is going to give me 10 over 2. This is going to give me negative 4 over 2, which finally equals 5, or it equals negative 2. My answers to this quadratic are 5 or negative 2. Once again, what does this mean? That means if I plug in 5, this would all equal 0. Or if I plug in negative 2, this would all equal 0. Now, we can factor this to normal A like we did on our first slide, right? You could factor this to normal way and be like, oh, the factors of negative 10 would be negative 2 and 5, and they add up to negative 3. Watch. Actually, did I make a mistake? Because it should be negative 5 and a positive. Oh, no, because these are equal to zeros. I apologize. It would be x minus 5 times x plus 2, but when you set them equal to 0, it would be positive 5, negative 2. I apologize. So these are your answers. These are the answers to the quadratic formula, the zeros, right? If we need to factor this, you would put this back as a factor, right? You just flip their signs. So x minus 5 times x plus 2, right? Whatever you get those answers, you flip their signs to put it back in the parentheses. So try your next one using the quadratic. Hopefully you tried. Let's just kind of run through it. So once again, A is equal to 1, B is equal to 8, and C is equal to 16. I forgot my equal sign. So we plug it in. X is equal to, we get negative B, so that'll be negative 8 plus or minus the square root of B squared. So that's going to be 8 squared minus 4 times 1 times 16. All over 2a, which once again is going to be 2 times 1. This is equal negative b, negative 8, plus or minus square root 64 minus 4 times 1 is 4, 4 times 16. So 4 times 10 is 40, and 4 times 6 is 12, that's 24, so that's going to give me 64. All over 2. What ends up happening here is this is going to give me 0. So then I get negative 8 plus or minus the square root of 0 over 2, which is equal to negative 8 plus or minus the square root of 0 is 0 over 2. Now, it doesn't matter if I add or subtract the 0 to 8. It's going to leave me with one answer, negative 8 over 2, which is equal to negative 4. So this quadratic only has one solution, which is negative 4. That means if I factor this, which we could tell, a 4 times 4 gives me 16, and 4 plus 4 is 8, right? This is also something that we call perfect square, which means I could just do x plus 4 squared would give me this. And that gets our answer. So now we have a quadratic, but this time we have a different leading coefficient. It's done the same way though. So a is now equal to 2. B is equal to 7. And C is equal to 3. So we say x is equal to negative b is negative 7 plus or minus the square root of 7 squared minus 4 times a, which is 2, times c, which is 3, right? All over 2a, which is going to be 2 times 2. And once again, we just solve. So negative 7 plus or minus the square root. 7 squared is 49 minus 4 times 2 is 8. 8 times 3 is 8 and 8 is 16. That's going to be what, 24? All over 4. So now this time, this isn't going to leave us with 0. It's going to be negative 7 plus or minus 49 minus 24 is 25, which we like. Reason is that's a perfect square all over 4. So we get negative 7 plus or minus 5 all over 4. Once again, it splits apart. Negative 7 plus 5 is going to give me 2 over, or wait, negative 7 plus 5 is a negative 2. My bad. Negative 2 over 4. Or we get negative 7 minus 5. That's going to be negative 12 over 4. This is going to equal to negative 1/2. That's one of our answers. And this will equal to 12 divided by 4 is 3. So negative 3. And these are your two answers to this quadratic. So once again, I suggest trying the next one yourself if you haven't. Pause the video. Welcome back. So we get A is equal to 5. B is equal to negative 4 because the minus sign's there. And C is equal to negative 1. So once again, we plug it in. And we get negative b, but negative 4, so that turns it positive, plus or minus square root of negative 4 squared minus 4 times 5, which is a, times c, which is, oops, I forgot an equal sign there again, negative 1, all over 2 times 5. So once again, we get 4 plus or minus square root. Negative 4 squared is 16. Then we got 4 times 5, which is 20, times a negative 1, which is going to give me a negative 20. But a minus a negative gives a plus, and this ends up equaling positive 20 all over 10. Now, this is going to equal 4 plus or minus the square root of 36 all over 10. 36 is a perfect square, so we get 4 plus or minus 6 all over 10. Once again, we split it. 4 plus 6 is 10 over 10. 4 minus 6 is negative 2 over 10. And then we just say what these are equal to. 10 over 10 is 1. Negative 2 over 10 is going to be negative, could simplify this, 1/5. And there's your answer. Now, there's one thing that is very important, right? If your square root ends up being negative, that means, here, not there. Here, if this ends up being, oh my God, this ends up being negative, or up here, if this ends up being negative, if they're negative, it means there's no real solutions. That's very important, because you cannot take the square root of a negative number. It would give you an imaginary number, which you have not talked about yet. So there would be no real solution. So once again, if in your square root it ends up being negative, that means there is no real solutions, and that means it wouldn't work. So let's take a look at our square root method. Now, your square root method needs to have a certain situation going on where you could square both sides, or take the square root of both sides. For instance, our first one, I could take the square root of both of these, right? Because x squared is x, And the square root of 64 is going to be plus or minus. You always do the plus or minus in this situation. And it's going to be, excuse me. Then your answer would be square root of 64, is 8. Because 8 times 8 is 64, but negative 8 times negative 8 is 64. Really what this means is x is equal to 8, or x is equal to negative 8, right? So we just say plus or minus 8. The way it works now with the other ones, once again, it is only certain situations. Right now, you're like, this isn't a perfect square, but watch what happens. If we divide by 3, that then gives me x squared is equal to 25. I can now take the square root of both of these. X squared is x equals 25 would be plus or minus 5. Once again, 5 times 5 is 25. Negative 5 times negative 5 is 25. That's why we have the plus or minus. Or we could have something that looks like this, right? Where we have something in our parentheses, x minus 5. But I could still take the square root. I could still take the square root of both sides. We could get x minus 5 is equal to 7, or plus minus 7, right? This then means x minus 5 is equal to 7, or x minus 5 is equal to negative 7. And now we just have to solve both of these. We add 5. That's going to give me x is equal to 12, or add 5, and we get x is equal to negative 2. Negative 7 plus 5 is negative 2. So then we end up getting these two answers, x equals 12 or x equals negative 2. But then we have something that looks like this. Once again, it doesn't look like we could take the square root, but I do see this 4 on the outside, so I'm going to divide it to get it away. So we get the square root, or we get x plus 2 quantity squared is equal to 25. Now it's like, oh, 25 is a perfect square. So we take our square root, and we get x plus 2 is equal to plus or minus 5. So once again, we have to set up our two equations. X plus 2 is equal to a positive 5, or x plus 2 is equal to a negative 5, right? Subtract 2, subtract 2. That gives me x equals 3. Subtract 2, subtract 2. And that gives me x equals negative 7. And there's your two answers to that one. That's your square root method. And finally, we have to do something called completing the square, right? So completing the square takes a little bit more work here, right? So what is completing the square? So completing the square is like when we have a quadratic like this one that we cannot factor yet because there is no number here that makes it factorable, or we can't find factors, right? So in order to complete the square, you're going to look at your middle one, right? Your b from earlier. And we're going to take b and divide it by 2. Whatever you get as your answer, you then take that number and you square it, right? And then that's what we're going to plug in. That will be your c, right? So what does that look like? Here, we're going to take 4 divided by 2, which gives me 2. Now I'm going to take that number, 2 squared, and that gives me 4. So this one just happens to be 4. But 4 is your c, so that's what I'm going to plug. Oh, I don't want to put c there. I want to put 4. 4. And what that means is we can now factor. But since we completed the square, what that allows us to do is then write the factor of x plus 2 squared. You take that number that we found here and you could square it, right? So what does it look like here? Well, right now, this is actually factorable, but it says to solve by completing the square. So what does that mean? For this type of problem, what we have to do is do, sorry, let me rethink. We're going to subtract 5 from both sides, right? Because we want to get rid of that here. And then what we do is we get x squared plus 6x plus, we're going to leave a blank, equals negative 5. And I want to fill in that blank, kind of like how we did up here. So we're taking our b, that's 6. And once again, 6 divided by 2 is equal to 3. That 3 squared is equal to 9. So I'm going to add 9. But if I do it to one side, I have to do it to the other side. I have to add 9 to the other side, right? Now, what this then gives us is x squared plus 6x plus 9 equals 4. Now I can factor this, right? So when I factor it, that's going to give me x plus 3 squared is equal to 4. Now this actually works out well, because what this looks like is kind of what we just did on the last slide. I could take the square root of both of these, right? And then we get x plus 3 is equal to plus or minus 2. Then we split it. X plus 3 is equal to 2, or x plus 3 is equal to negative 2. And we subtract 3, subtract 3, subtract 3, subtract 3. On our first one, we're going to get x is equal to negative 1, or x is equal to, negative 5, which would have been our answers in the first place in order to get this this here, right? We would have got x, the factors would have been x plus 5, x plus 1 would have factored this in the first place, but we factor it with completing the square. So let's just solve one more, right? So let's solve this one. And this one is more of a problem that you'd see where you'd be like, oh, we have to do it completing the square. The reason is factors of 7 are 1 and 7. That doesn't give us 10 when we add them together. So we have to complete the square. So let's subtract the 7 over, right? And that's going to leave me with x squared minus 10x, leave your blank, is equal to negative 7. We're going to pull that negative 10. So we get negative 10 divided by 2 is equal to negative 5. But when I take that negative 5 and square it, it's going to give me 25. So we're going to add 25, add 25. Now, this time, what we're going to do is we're going to factor this. But we need to take this number here. So it's going to be x minus 5 squared is equal to, and then we add these, negative 7 plus 25 is going to give us an 18. All right. Now, from this point, we can't take the square root. I mean, you could, but it's going to give you a decimal. We're not going to get whole numbers here. So this is where we kind of end up leaving off, right? You don't really solve it from this point. Or actually, you don't solve it from this point. You kind of just leave it here. If you want to solve it, we could do this, right? You could say, you take the square root of both sides, right? And then you would be able to get, x, sorry, I'm going to come over here, x minus 5 is equal to, you would say plus or minus the square root of 18, right? Which then you would subtract 5, which would then give you x is equal to 18, square root 18 minus 5, or x is equal to negative of whatever this square root would then be, minus 5. And those would be your two answers, right? So let's try our last one. Once again, I recommend you try it yourself. This one will have an answer, more like the ones on the previous slide. So if you did try it, once again, we're going to subtract here. And then we're going to notice something here. So minus 36, and we get x squared plus 12x. And then we leave plus blank is equal to negative 36. But we're going to take this 12. 12 divided by 2 is 6. Wait a second. 6 squared equals 36. We're just adding that 36. The reason is that this was already broken up. So when I add that to both sides, it's going to bring me back to what we originally had. But it's sometimes if you're like, I'm unsure and you want to complete the square, it ends up allowing you to be like, oh, okay, that is perfect. So then we could say x, once again, this is a positive 6, so x plus 6 squared is equal to 0. And then you could take your square root. Square root of 0 is 0. So we get x plus 6 is equal to 0. If you want to solve it, you could subtract 6, and we would get x is equal to negative 6. And there's our answer. And there we go. That is all we got for today. That should be everything that we could cover in factoring, a brief overview. I hope that we learned something. If you got any questions, let me know. And good luck.